Hello everyone, my name is Rasel Ahmed. My ID is 12308045. Today I want to talk about flip-flop. What is flip-flop? Flip-flop is a term that comes under digital electronics and it is an electronic component that is used to store one single bit of information. Since flip-flop is a sequential circuit, so its input is based upon two parameters. One is the current input and other is the output from previous state. It has two outputs, both are a complement of each other. It may be in one of two stable states, either 0 or 1. There are many kind of flip-flop: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. What is RS flip-flop? The RS flip-flop is used to store binary information 0 or 1. It consists of two inputs, S means set and R means reset. The flip-flop keeps its present state even when one or both inputs are deactivated. The flip-flop enters the 0 state when the reset input is activated and the 1 state when the set input is activated. There are two ways how we can construct an SR flip-flop. One is NOR gate and another is NAND gate. Basic block diagram of SR flip-flop. There are two input S and R and between them is clock pulse. Q and Q prime is the complemented output. RS flip-flop circuit with NOR gates. In figure 5.5, an RS flip-flop containing two NOR gates has been illustrated. It should be remembered about NOR gate that its output is 1 only when all of its inputs are 0. And when any of one or both of the NOR gates inputs are 1, its output is 0. When both inputs are 0, that means R is equal to 0 and S is equal to 0. In this situation, NOR gates inputs have no influence whatsoever on its output as long as input condition of flip-flop does not change. As such, flip-flop remains on its present or normal state, i.e. no change occurs in the value of Q, which has been illustrated by the first line of its truth table. Remember that if S input becomes 1 for a moment, flip-flop moves on the set state. Similarly, if R input goes on for a moment, in such a situation flip-flop shifts to the reset or a clear state. When value of R is 0 and value of S is 1, in such a situation, output of the bottom NOR gate becomes 0 or low. As output of bottom gate is also an input of the top gate, in this way both input of the top gate become 0 or low. Resultantly, output of the top gate becomes high or 1. As such, flip-flop sets when input else becomes 1. Remember that when flip-flop output Q is 1, this stable state of flip-flop is called set. This has been demonstrated by second line of the truth table. When R input is 1 and S input is 0, the output value of top NOR gate becomes 0 or low. As output of top gate is an input of the bottom gate, hence both inputs of the bottom gate become 0 or low. As a result, high output is obtained from bottom gate. Therefore, applying 1 on R input, flip-flop resets on a stable state, which is known as a clear state of reset state. When both inputs are 1, a forbidden state prevails on flip-flop. As a result, outputs of both NOR gates become 0 or low. In other words, values of Q and Q becomes identical or same. As this thing is absolutely opposite to the rudimentary definition of a flip-flop. RS flip-flop circuit with NAND gate. In figure 5.5a, a basic RS flip-flop circuit consisting of two NAND gates has been depicted. It must be remembered regarding NAND gate mechanism that when both of its inputs are 1, its output becomes 0. And as a result of any one or both inputs being on 0 or low, NAND gate's output becomes 1 or high. Operation: when both inputs are 0, then both outputs become 1. This state is called forbidden or a prohibited condition. Flip-flop is never made to act in this state during normal operation, as has been illustrated in the truth table. According to second line of the truth table, when S input is 0 while R input is 1, then in such a situation, output Q becomes logic 1 and output Q becomes logic 0. Consequently, flip-flop passes on to a set condition. When S input is 1 and R input is 0, output Q becomes reset. This condition is also known as clear state, as has been illustrated by line 3 of the truth table. When both inputs are 1, in such a situation both outputs retreat on to its previous or last condition. Resultantly, no change substantiates This condition of any flip-flop is known as a hold condition. It has been exemplified through line number 4 of the truth table. Now we say about clocked RS flip-flop. The clocked flip-flop uses two AND gates A and B at the input stages, and common input of both AND gate is named as clock. These two AND gate will supply an input S and R to RS flip-flop to operate when and only when clock is high. If clock is low, using and don't care condition of AND gate, R and S input becomes 0 or disabled to provide input to RS flip. Now we say about what is JK flip-flop. Unlike the JK flip-flop, the basics S and N flip-flop circuit has many advantages of and uses in sequential logic circuits, but it suffers from the two basic switching problems. The set 0 and reset 0 condition must always be avoided. If set or reset change state while the enable input is high, the correct latching action may not occur. Then to overcome these two fundamental design problems with the SR flip-flop design, the JK flip-flop was developed. The basic JK flip-flop, both the S and R input of the previous SR bistable have now been replaced by two inputs called the J and K inputs, respectively after its inventor Jack Kilby. Then this equates to J equal S and K is equal to R. The two input AND gates of the gated SR bistable have now been replaced by two 3-input NAND gates with the third input of each gate connected to the outputs at Q and Q. This cross-coupling of the S flip-flop allows the previously invalid condition of S is equal to 1 and R is equal to 1 state to be used to produce a toggle action, as the two inputs are now interlocked. The truth table for the JK function is shown here. Then the JK flip-flop is basically an SR flip-flop with feedback which enables only one of its two input terminals, either set or reset, to be active at any one time under normal switching, thereby eliminating the invalid condition seen previously in the SR flip-flop circuit. However, if both the J and K inputs are high at logic 1, when the clock inputs goes high, the circuit will toggle as its output switch and change state complementing each other. This results in the JK flip-flop acting more like a T-type toggle flip-flop when both terminals are high. Thank you very much.